Hi everyone, I'm doing teacher Parinya's assignment. Uh, that contains the problems I have to do. So let's get started with the first question. The first question basically asks the direction of the rate of change of electric field that cause the corresponding direction of the magnetic field line. So ostensibly, this problem must be related to Maxwell-Ampères equation. Um, Instead of the normal current or conduction current I, we see the electric field. But don't worry, because in Maxwell Ampères equation, there's also another term beside conduction current, which is displacement current. The displacement current, or ID, is equal to mu 0 epsilon 0 d flux by dt. The constant doesn't matter. What we are looking for is the direction of the rate of change of electric flux. Well, the area is constant, so we don't care about the area. What does we really care about is electric field. Okay, so I can simplify it as a times dE by dt. Okay, so let's see the direction of electric field. So the first the figure A, the direction of electric field go like this, right? By the right hand rule, the change of electric field must go upward. But since you see the direction of electric field is downward, so dE by dt must be negative, right? Or more specifically, the rate of change must be like this, right? So electric field must be decreasing in the from the figure A. Okay, so we can filter out the choice 3 and choice 4 because it stated that the E increasing in A, which is not the case. So let's look at the figure B. Again, with the right hand rule, we see that dE by dt must go like this, right? But since we see the figure show that the original direction of electric field go like this, so the direction the magnitude of electric field must be negative or decreasing. So dE by dt will go this direction, right? So the electric field in figure B must be decreasing also. So the final answer is number 2, of course. Next, I choose third question. So it asks, what is the greatest displacement current through the area during the given time period? So as I previously mentioned, the value of displacement current is mu 0 epsilon 0 d flux by dt. So since the flux is E times area, okay, which is equal to pi they already given a cross-section area, okay, so it is 2 meter square, 2 square meter, sorry, and it actually shows the value of E, but we don't really care much about it. What it really does matter is the change of the rate of change of electric field. So you look at the picture and also know that we don't care about the direction of the changing flux. Okay, we look at only like a magnitude or absolute value. So as you see, this section has the highest slope, which is like around let's calculate 6 minus 2 Newton per coulomb by 6 minus 2 microsecond, which is like 10 to the negative 6 second. So it is 1 times 10 to the 6. Yeah. So be careful of significant figures. So it is only one. Okay, we got that. We got the the rate of change of electric flux is dE by dt times 2.0. The highest one is 1 times 10 to the 6, right? So the answer is 2 times 10 to the 6 Newton per coulomb second. Okay, and we just compile all together. We got the value of mu is approximately 4 pi times 10 to the negative 7 times epsilon 8.854 to the negative times 10 to the negative 12. Yeah. I will use the calculator. 4 pi 8. Okay, we got right around. Be careful of the significant figure, okay? And unfortunately, we got only one. We got 2 times 10 to the negative 11 ampere. Okay, so yeah, here's the answer. Very, very insignificant current. And the last question I choose is the question 4. The voltage across a parallel plate capacitor with area A and the separation D varies with time as voltage equal to AT squared, where A is a constant. Find the displacement current between the plate. Again, this problem is about displacement current. The voltage is given, the separation D is given, and the area A is given also. So let me demonstrate the situation first. So we have a parallel plate capacitor, right, with voltage across equal to V. Let's make the assumption where area, or more specifically square root of A, is much higher than D. So we can make a assumption that E is equal to V over D. Okay, and we got AT squared over D. Why we calculate electric field, right? So as I have previously mentioned before, the displacement current is related to the rate of change of electric flux. Okay, which of course, electric flux is related to electric field. So right now we already got electric field. Then we calculate electric flux. We just multiply by A, because in a parallel plate situation, like electric field is obviously perpendicular to the plate. So we can just multiply them together. For those who ask, it should be dot product, but you know it is perpendicular. So yeah. Then we just we differentiate. I mean partially differentiate with the respect of time. We got 2a capital A times AT over D. Okay, and then we just multiply all together. Finally, we got 2 mu 0 epsilon 0 capital A times AT divided by D as a final question. And that's a good place to stop.